Hello, so today we're going to go over the scientific notation pathway in Study Island. I'm sorry that Blackboard was acting up on us the other day, so we couldn't do this in person, but hopefully we'll be able to get through most of this today and you'll have a better understanding of scientific notation. Alright, so the first rules of scientific notation is that the number from 1 to 9 must be before the decimal point, and then we use the exponent of 10 to hold the value place. So that's like if we have the number 125. We have to make sure that there's only 1 or 1 to 9 before the decimal. So if our decimal originally is here, we can move that to here. So now we have 1.25. We go to times 10, because that's going to be our placeholder. And now we have to know to what exponent we are putting it to. So you go, how many places do we move over? We went over 1, 2, and since it was to the left, it says positive, so we can keep this as a positive 2. So down here you look, when the decimal is moved to the left, the exponent gets larger, but when the value stays the same. So this first little bit here does not change. Okay, so the numbers stay the same. We're just moving the exponent. If you move the exponent to the right, it makes the exponent smaller by 1 for each place moved. So if we had 0.025, we'll move this decimal point 2 spots to the right. So now we're going to have 2.5 times 10, and now since it was the right, we're going to be moving it to the negative 2. So anytime you see that negative exponent, realize that this first number is smaller than 1. Alright, and here is going to get some of the adding subtraction rules that we're going to go over today. So we're going to add and subtract scientific notation. The exponents must be the same first. When you're multiplying, you find the product of the numbers, then add the exponents. When we divide, we're going to divide the numbers first, and then we're going to subtract the exponents. And then if you want extra practice, if you go to this, type this into your browser. Here are some examples of scientific notation. So if you look here, we have 10,000. So that's 1 times 10 to the 4th, because we move the decimal place over 1, 2, 3, 4 times. So this side gives you nice clean numbers to look at. When you're looking over at this side, it helps you see when you have different numbers. So in this case, 1 is our only significant digit here. But over here, we have all of these are significant digits. So when we do the decimal, or do the actual notation, we still have to show that. So use this as a reference so that if you do have a question about how something should look, you can do that. Alright, so here we're going to estimate the following number. So we have 299,792.458 kilometers per second. Alright, so first we need to figure out what number are we going to round this to. The easiest number would be the 300,000. And that's, of course, don't forget your units. Okay, we did that because the 9, since it's larger than 5, it rounds the 2 up to a 3. And so now we have to figure out, we have to put that number into scientific notation. So we're going to be moving the decimal point over 1, 2, 3, 4, 5 places. So we know that it's going to be 3, times 10. How many places did we move over? We moved it over 5 places. Did we move it to the left or to the right? We moved it to the left. Therefore, we keep it as a positive 5. So we know that this is our answer. And then we can look and see that C matches that. So we know that C is going to be our correct answer. Alright, so now we're going to simplify this form. So we got to make sure that we're looking and realizing that it is subtracting. So what I find the easiest, since these exponents are smaller, not like you're going to 10, is just to go ahead and write this out in the expanded form. Now you can just divide it out, and remember you have to put in these zeros here. You can't take 2 from 0, so we can't borrow from this 0, so we're going to come over here, make this a 5. Normally you would make this a 10, and then you would have to borrow another 10 from it, so you can just write this as 9. You can make this a 10. So 2 from 10 is 8. 3 from 9 is 6. 0 from 5 is 5. And 0 from 8 is 8. We still got these 2 zeros here, so you cannot forget about writing those down. So now we can put that back in scientific notation. So we're going to move the decimal point 1, 2, 3. So we know it's going to be 8.56 because they're all significant digits. Times 10. We moved it 3 spots, but which way did we move it? We moved it to the right. So therefore it's going to be a -3. Alright, so here, now instead of subtracting, we're going to multiply. So you can go 6 times 8, which is 48. And now with our exponents, we can add them. So you can go 5 plus a -2. So that's going to give us 3. So it's like 5 minus 2. So 48 times 10 to the third. But is this complete? Is this my final step? No, because remember the first rule of scientific notation is that you only can have one number before the decimal. So here, our decimal is actually after the 8. So we have to move that decimal place over 1. So we're going to have 4.8 times 10. Now we moved over the decimal place one more spot. So now this 3, we're going to add 1 to it because we moved the spot over. So now it's going to be 4. Okay, so 4.8 times 10 to the 4th would be our final answer. Alright, so now instead of multiplying, we are dividing. So you can rewrite this as 4.5 times 10 to the 4th. Divide that by 9 times 10 to the 5th. So now you can do this first part first. So take 4.5 divided by 9. And that's going to give you 0.5. So 0.5 times 10. And now here we subtract. So we can go 4 minus 5. Move the decimal back 1. So it'd be -2. Okay, so now we are going to add. So if I make the exponents the same, so the smaller one, we can turn this into 13. So you have 2.3 times 10 to the 13. Now if I take this and make it 13, we'll have to come over. So it's going to be, so now that we have that our exponents are the same, they're both 10 to the 13th, we can just add the 2.3 and the 0.0022 together. So we're going to get 2.3022 times 10 to the 13th. Alright, here what we're going to do is that we can either put this one in the scientific notation and then add it to this one. So this here we can go 1, 2, 3, 4. So you're going to get 32. You're going to get 32 plus 2.5. So that's going to give you 34.5 times 10 -4. Now is that our final answer? Nope, because you're going to have to move this decimal over, because remember you only can have one out in front for our final things. So you're going to get 3.45 times 10. Do we keep it as the -4? Nope, because we are moving it back to the left, so we can actually add 1 to the -4. So that's going to leave us with -3. Okay, here, so we're just doing another subtraction. So once again, we can make the exponents the same. So in this case, we're going to have 43 subtract 2.8, and that's going to give you 40.2 times 10 to the -5. Okay, so these really do have that 10 to the -5 on them, but since the exponents are the same, we can just work with the first part of the numbers. So now, is this our correct answer? Nope, because we need to move that decimal place over. So we're going to get 4.02 times 10. And since we moved it over to the left, we're going to add 1 to that -5, so that's going to leave us with a -4. So that would be my final answer there. Okay, so here we are going to multiply. So the easiest way to do this is to put this last part into scientific notation. So then we're going to have 5 times 10 -7 times 5 times 10 -5. Okay, so now our front numbers can stay the same. So 5 times 5 is 25. And now since we're multiplying, we can just add our exponents. So -7 plus -5 gives you 10 times a -12. But once again, we're not done yet because we have to move this decimal place over 1. So we're going to get 2.5 times 10, and because we move the decimal place over to the left, that means we're going to add 1 to that negative 12, so that's going to give us a negative 11. Okay, so here we're just going to divide against, which means we can turn this one into scientific notation. So here we can do this first part here. So 3.2 divided by 8, and that's going to give us 0.4. Now for our exponents here, this is the same as saying negative 3 minus a negative 3. So that's another way of saying negative 3 plus 3. So that actually gives us 0. So, but we still have that decimal place here that we have to move back 1 to give us that whole number out front. So then it's going to be 4 times 10. And how many places did we move the decimal? We moved it to the right 1. So it's going to be towards the negative side in 1 spot. So 4 times 10 to the negative 1 will be our final answer. So the length of an object is measured as 75.7 centimeters. What is the measurement in scientific notation? So we can just start with the 7.75.7, and we just want the 1 space before the decimal. So move that one over. So then we get 7.57 times 10. How many spots did we move over? We moved it over 1. And don't forget your units, so centimeters. Alright, so here, we'll just do some extra practice. So we can go over 1, 2, 3, 4. So we know we're going to have 10 to the negative 4th. And we just have the 2 out front here. And don't forget your units. So same thing with this one here. Just 1, 2. And it's to the right, so we know it's 10 to the negative 2. So on this one here, we're going to move it to the left. So 1, 2. So you can get 2 times 10 to the positive 2. Okay, so 20,000 centimeters. 1, 2, 3, 4. So 2 times 10 to the 4th power. So be careful. Make sure you realize which direction you are moving that decimal, so you know if it's a positive or a negative. Alright, so here we're going to take the top numbers and put them into scientific notation. So 3,394 kilometers, we are going to actually round first. So we can just round it to 3 or 3,000 because this 3 is smaller than 5. So then we move the decimal place over 1, 2, 3 spots. We're going to the left. So we're looking for something that is positive. So we can automatically get rid of this one because it says negative 3. And we only went over 3 spaces instead of 4. So we know this one's not correct. And this one is. So 300 million meters per second. We can go over 1, 2, 3, 4, 5, 6, 7, 8 times. And we move to the left, so we know it's positive. So we want to know that it's 8. We want a positive 8. Right, there's the answer. And this one here, we're going to go over 1, 2, 3, 4, 5 spots. But we went to the right this time, so we want a negative 5. So we can get rid of this one. Oh, no, this one says negative 5, and so does this one. We have to look at our rounding. So we have the 8 here, but this 9, since it's higher than 5, is going to push this 8 higher. So it's going to give us the 9 times 10 negative 5. Alright, here, so we're just going to estimate some weights and heights of certain things. So a pencil is small. If you think of a pencil, it's definitely less than a pound. So you want to make sure you have a negative exponent. The radius of the Earth, you want to make sure we're in kilometers, and it's going to be a large positive number. So you're going to be looking for a large positive number. Seconds, well, we know there's a lot of seconds because there's 60 seconds to a minute. You know, there's 60 minutes to an hour, so you have to times 60 by 60 to get how many seconds are in an hour, and then times that by 24 hours, so you know that's going to be a large number of seconds. So make sure that you have a large exponent, and make sure your units are matching. The wavelengths are actually really, really, really small, so make sure you have a really small exponent. And your skyscrapers, make sure you have the right units there, and that when you put it in standard form, it makes sense. Alright, so here, I know you can see the answers already, but that's okay. So if you're given this on your calculator, that E means the same as times 10. Okay, and so this negative 6 here will actually be your exponent. So then you can just take this number, move it over 1, 2, 3, 4, 5, 6, and that would be your number in standard form. Same thing over here. That E is that times 10. Your exponent then is that negative 5. And that would be your standard notation. Okay, so here's a couple of the word problems that you might run into. So if you look at the radius of the Earth at the equator is approximately 6 times 3 kilometers, while the equator radius of Saturn is approximately 10 to the or 6 times 10 to the 4th kilometer. So we want to know which of the following is true. So does that mean that the radius of Saturn is 100 times larger than the Earth? Does it mean that it's about 10 times? So I'll underline the parts that are different here. Is it approximately 100 times? So be careful if you're looking at Saturn to the Earth or Earth to Saturn. Or is it 10 times going from Saturn to Earth? So you always want to have the larger of the two first. So we know that Saturn is the larger one. So anything that has Earth first, we can get rid of. And now, going from times or 10 to the third to 10 to the fourth, is that going to be 100 times greater or just 10? So if you have So is that only a times 10 difference or is it times 100 difference? Yep, it's going to be only 10 difference. That's why we have that 10 as our base number there. Okay, so here's another one. So the Earth is approximately 2 times 10 to the 7th kilometers from Venus, when Venus is at its closest approach to us. The Earth is also about 4 times 10 to the 13th kilogram from the star. So which is true? So go ahead, pause this for a second, read through those, and see if you can figure out the answer. And the correct answer to this one is D. The distance from Earth to the star is approximately 2 million times the distance from Earth to Venus. So that you have to look at the exponents again. Okay, the mass of an electron is approximately 9 times 10 to the negative 28th grams. Sorry that I cut off there. While the mass of a neutron is approximately 2 times 10 to the negative 4th grams. Which of the following is true? So take a second, read through those, and see if you can find the answer there. So the answer here is going to be D. The mass of the neutron is approximately 2,000 times the mass of an electron. Because remember, that the neutron is definitely heavier than your electron. By how much? By about 2,000 times. Okay, here the international border between the U.S. and Mexico is approximately 1.951 times 10 to the third miles in length. So what is this distance in standard form? So we just have to move this decimal back place over 1, 2, 3 times. And that's going to get rid of this for us. So then it's going to be 1,951 miles. So our answer here would be B. Alright, make sure that you are saving the whiteboard or saving the PDF off my website. Make sure that you're going and doing the scientific notation pathway right now. If you don't get the first time, do a couple of the lessons on there, review again, and then try to get that blue ribbon. And if you have any questions, please let me know. Thank you guys so much.